And we've learned all the equations of lines that we need to. So kind of like the problem I did on the last section, that was a mathematical model. We can model supply and demand equations, and then we can answer questions based on that model. So we're going to be looking mostly here at what we call a linear model, which of course that's what we've been studying. We know that y equals mx plus b is the general equation of a line, where m is the slope and b is the y-intercept. That's what we did on that problem at the very last section, 1.2. So this is, you're not going to really do anything on this page. This is just a mathematical model. So what this is saying is this is a price of a taxi cab ride. So this is the number of miles. That's the cost. Okay, now that's the way a taxi cab, I don't know, taxi cabs are going out of business, I think, because of Uber. But used to in a taxi cab, you would see the thing kind of run through and your price would be computed as you go like that. So every time you drive another mile, it goes up. Now, one thing I want you to notice on this is going up 30 cents. Every time you go a mile, it's going up 30 cents. That's what happens on a linear relationship. It means if the x value goes up 1, then the y value should always go up by the same quantity. Okay, so that's a linear relationship. That just means that every mile is 30 cents. Does that make sense to you? Okay, if you graphed these points, then you would find that you have a straight line. So we have the number of miles that way, then we have the cost that way. That's what I want you to see in this page, is the reason it's linear is because it just keeps going up the same amount. Does that make sense? Okay, that's what a linear relationship looks like. Okay? All right, so on the next page, I'm going to kind of show you what I want you to know on this. So these are just things that I want you to be able to look at, a set of numbers, and tell if it's a linear relationship or not. And it's actually easy to do this, so watch carefully. Okay, so it goes like this. Let's see if this one's linear or not. Okay, first of all, what is x going up by? Up 2. It always is, right? What is y going up by? Up 6. So that's linear, okay? So the answer to this is yes, that would be a linear relationship. Okay, if x goes up the same amount, so does y. It doesn't matter that it's a 6 or whatever, it's just that it continues to go up 6, okay? All right, the next one, what is x going up by? Up 1. How about the y's? Let's see. It goes up 3, then it goes up 5, up 7. Is that linear? No, it's not linear because it keeps going at different rates. So that's not linear. Okay, does everybody understand that? Tell me. Okay. Okay, so it's got a constant rate of change. All right, so I'll give you a minute to see if you can figure these out. Okay, look at the 3 tables I gave you and just write yes or no whether you think it's linear. You can do it in your head or you can write down what you need to. You're just looking on there to see if the x's go up the same, so do the y's. That's the question you ask yourself on that. That's how you can tell if it's linear. Okay, let me ask you this question. How many of these things are linear? I can do that kind of in my head. You can too. What do you see? 2. Which 2? The last 2, okay? So this one right here is always going up 1. This one is also always going up 1. So therefore, yes, that one is linear, okay? The next one goes like this. That's always going up 1. This one is always going up 25 cents, right? So that's linear. Does that make sense? Okay. Now the next one, this one's going up 1. The x's are getting bigger by 1, but notice what's happening. This one's going down 5, then it goes down 3, so it's not linear. Okay, so that one is a no. Any question on that? Okay, good, bad. Okay, thank you. Okay, so that's what you want to be able to tell is take a set of data and tell if it's a line. So basically on those last two, if you plotted the points, they would make a straight line, and you would see that. But that's how you can tell it's linear. Okay, this is just a review right here. We've been working on slope, so I'm not going to go over anything here. We've already learned the slope formula, but we're going to revisit this in this section a little bit. Okay, so let's go to page 3, and then we'll start kind of putting together some applications here. All right, so here's the situation. It says a physician published the following estimate of ideal body weight for a woman. What they're saying is 49 kilograms, just flat out, okay, and then if you're over 5 foot tall, it should be 1.7 kilograms for each inch over 5 foot, okay? This is a linear relationship, so the idea is the taller you are, the more you weigh by a certain amount. Okay, so what you get here is the 49, that's what's called a fixed, not a fixed cost, a fixed height, okay? That's basically, that's the height of somebody that's 5 foot, or the weight, I'm sorry, not height, weight. Okay, so that's kind of like a fixed weight of a woman that's 5 foot. Okay, like that. That's the ideal. Okay. All right, now what is the 1.7? The 1.7 is a variable weight like that. So what we're going to do is we're going to find a linear model for that. So what we're used to having is y equals mx plus b. That's what we're used to having. But the variables are different now. Okay, so what it is x is going to be like the height. Okay, and then y is going to be the weight. Okay, that's what it says. And there is w is the weight, and then we're going to use h for the height like that. Okay, so we're going to use w there, and we're going to use h there. Okay, so what we would have for our equation is w, the ideal weight, is, and then that would be m times h, let's use lowercase, okay, like this, and then plus b. Okay, so that's what that means. All right. Okay, well, let's see what we have then. All right, let me see if you've caught on to this. Which one of these is the fixed, the m or the b? Which one? The b. This is the fixed. Okay, so that's given as 49. Which one's the variable? 1.7. Okay, like that. So that means your mathematical model is w equals 1.7 times h plus 49. Okay, that's a linear relationship that does that. So here's what this does. And tell me if this makes any sense or not. Okay, so the 49 is what? That's if you're 5 foot tall. That's what the problem says. What does this 1.7 do? That's if you're taller than 5 foot, what does that do? That's an extra weight. So every time you're 1 inch taller, 1.7 kilograms more is what you should weigh. So that's 5 foot, that's where you start, and then that's bigger depending on what your height is past that 5 foot. Does that make sense? Okay, all right. So what we're going to do is just kind of do an interpretation, and that's what I just told you, is basically this. So let's just write this down kind of like this. 49 kilograms is the weight for a 5 foot tall woman. Okay, that's what that is. Okay, and then the 1.7 kilograms is the weight. This is a variable weight, so that's going to be the weight for each additional inch. Okay, that'll be each additional inch past the 5 foot. Okay, that's what that means. Okay, is that making sense to you? Okay, well, you're going to do stuff like if you're studying business and economics and stuff, you model stuff. Okay, you're learning the nuts and bolts, the mathematics to help you with this. But you're going to do models and stuff in the real world. That's what you model things with mathematics. Okay, so let's see if we can figure out how to do this then. This part C says a woman's 5 foot 4 inches tall. Predict what the weight should be. Okay, so this is what you're going to do. We're going to use the model we came up with. Now let me see if you guys really understand what I'm talking about or not. I don't know. Let's find out. What would I plug in for H in this problem? 4, exactly. Okay, because this is already the 5 foot. If you're 5 foot, that's how much you weigh. So you're going to plug a 4 in there, and then you'll get that ideal weight. So you have to understand the meaning of that then. So H is going to be the 4 inches, so you'd have W equals 1.7 times 4 plus 49. Okay, and then that'll give the ideal weight. Of course, you can just do that on your calculator. So I do 1.7 times 4, you can do it in one step, plus 49, and you're going to get 55.8. Okay, kilograms is the ideal weight. So that's it. All right. Okay, so that's how you would compute that out. So this mathematical model only works for 5 foot and above. Okay. Okay, this says a woman is 60 kilograms. The question is, what is the height? So again, I would start by writing down the mathematical model. Okay, what are you going to plug into your equation? And where? 60 goes in where? W, because that's what it is, right? That says this is a weight, so the 60 goes there. The height is what we don't know. That's what we're trying to find. So you're going to solve an equation on this problem. So you have 60 equals 1.7h plus 49. Okay, that's a real simple equation that you should be able to, I think, solve okay. So let's go ahead and get this solved. Okay, so I'll subtract 49 from both sides. Okay, that's going to give me, let's see, that's what, 11 equals 1.7h. Divide by 1.7, and this will give you the height. So let's see, 11 divided by 1.7. Okay, so that's given H is about, I'm getting about 6.5.
Don't you have to add
Okay.
to 5 feet?
Yes. So I was getting ready to ask the question. So the woman's 6.5 inches. No, how tall is the woman?
5 feet 6.
5 foot 6.5, right? Okay. Okay, so the height is going to be equal to, what you'd have to do on that is, that gives you your inches on there. So what you'd end up having is 5 foot plus the 6.5 inches. So it would be 5 foot, 6.5 inches, right? Okay. It's bigger than a Barbie doll, in other words. This is a grown woman. Okay. Does that make sense? Okay. Yes. No. Okay. Good? All right. Okay, so that's just kind of a simple mathematical model that's linear because it's given you kind of a starting point, a y-intercept, and then a variable on there, a variable change. It's been given a slope. So the hope is that some of these problems give you a little bit better sense of what slope and y-intercept are actually measuring in a context of a problem. Okay? All right, any questions on that? Okay, so that's kind of the first couple of things that you want to know. And when we go to the next thing, we're going to start doing what we call scatter plots, and we're going to do what we call a line of best fit, which you'll do on your calculator. Okay. Okay, so on this next page, so I've given you this data, and what this is this is given the year, and it's given the production level of energy that's fossil fuel. Okay, right now fossil fuel energy level is, we're trying to make it go down. Okay, because it's a finite resource. So that's why we're trying to transition to renewables. Now, what will change the world radically is if nuclear fusion becomes available, then the world will change radically, because that will be all the energy we will ever need. So they're working on it, and we're probably about 20 years off of it, but you guys are young enough that when that comes out, There is no more wind power. There's no more solar. We don't need it. It's just fusion. And fusion is 100% safe and has no pollution. So that's kind of where we might be going. But we're not there yet because it's very complicated. You can only fuse two atoms together if you have something that's millions of degrees. So a little side note there because it's just something that I was thinking of. Okay? So the context of the problem is you've got the percentages changing as time goes on. So what we're going to do is you're given a model for this, and we're going to use that to make some predictions. We're going to draw a scatter plot first of all. Okay, so here's what you want to do. If I have you draw a scatter plot, then what you're doing is you're just drawing a graph. You're just kind of plotting points. One of the key things is if I ask you to do a scatter plot, you got to label everything. So first of all, this X is going to be, and this is important when you read this, it says X represent years past 1985. So what we're going to do here is we're going to write this like this. We're not going to start at 1985. We're going to start at 0 and then just count by 1 each time. And it looks like we need to go out a little further than that. So let's kind of go like this. So between 1985 and 2015, what is that? That's 30 years. Okay, so let's make the graph go out to 30. So let's just count by 5. Let's go 5, 10, 15, 20, 25, 30. Okay, that's X. And what you would want to write on your graph is this would be X years past 1985. Okay, so again, what your graph is saying is this. It's saying that would be like 1990, 1995, 2000, and so forth like that. Okay, that just makes the mathematical model a little easier to work with. Okay, then what goes here, the y-axis is production. You can just say production percent of fossil fuels. Okay, so this should show maybe a decline. We'll see. Okay, so what we're going to do on that, if you look at this, the biggest number I see here is 85 is the biggest number. Okay, so what we want to do on this, and this is something you can do, okay, you can put this, instead of starting it at 0 and then going all the way up to like, 80 and stuff like that, you can put this little squiggly line, and then you can start this at, let's start it at 75. Okay, because the smallest number I see there is 78. So we can go 75, 80, and 85 like that. And the thing about it is you want to spread it out so, you can see the scatter in the data like that. Okay, so that's a good way to get everything set up. You can use that squiggly line so that you don't have to, go all the way to 80 or 90 like that. Okay, now what I want you to do is real simple. We're just going to plot these points. So it goes like this. Now this would be 0, 5, 10 on the x-axis because this is years past 1985. So what you're going to do is you're just going to plot those points. So it goes like this. You would go 0 and then 85. You put a dot there. Then you go 5, 83, and so forth like that. So all you're doing is just plotting points. You're not going to connect the dots. We're just going to see kind of what this looks like. So what you want to go ahead and do, line by line, plot the points. So we have 0, 85, just put a dot there. Okay, we have 5, 83, just estimate. Then you have 10, 81. Then we have 15, 80. And 20, 79, so it's a little lower. 25, 78. And then finally it looks like 25 and back up to 80 like that. So that's called a scatter plot. And we do this all the time in the real world. This is how we figure out relations. Does that look like a perfectly straight line? Perfectly straight? No, it's kind of straight, okay? So what we could do, just by looking at that, it looks like we could make a mathematical model for that. So that would be the idea. That's your scatter plot. That's what you do, okay? Now what we're going to do is we're going to take the model you were given was this. That's a mathematical model. I'm going to show you before class is up how you can use your calculator to get a mathematical model for this. Okay, so let's write down what that is. That is giving y equals negative 0.19x plus 83.75. Okay, so the question is what does this slope mean? Okay, all right, now a lot of times students on a test or say, on this they'll say rise over run. That doesn't tell me anything. You're telling me what it means in the context of the problem. This is the thought process I recommend that you go through. Okay, well, the slope represented by m is negative 0.19, but put it over 1. Okay, yes, it's a rise over run, but what this means is, that means years. X is years, so that would be in one year, and then this right here is the percentage. So this is what this tells me. Okay, this graph is sloping downwards, right? That's why you have a negative slope. So what this means is every time a year goes by, what's happening? The percent's going down by 0.19%. It's going down because there's a negative there, okay? So basically rise over run, but you got to know that X is years, Y is percent, like we did. So based on that, a good way to interpret this would be to write something like this. It'd just say, for each year, you just say the percent of fossil fuels. There's a lot of ways to say this. This is kind of what I'm after. Fossil fuels goes down by, and then we would just say 0.19%. You don't have to put negative 0.19 because that just tells you it's going down. So that's the idea. If you're interpreting a slope, which is important in here to understand what these things mean, that's how you figure it out. Put it over 1. The 1 means another year, you're going down. Okay, so on the average, that's what's happening. Every year, we're going down 0.19%. Does that make sense? Okay. All right. Now, what we're going to do is use this model to predict the year 2025. Okay, so here's what you do. You want to write down the model. And then we just do a simple calculation to predict what the percent's going to be in the year 2025. Okay? So first of all, this is what you have to understand. X equals 0 in what year? What did the problem say? 1985. Okay, we're at 2025. Okay, so just figure out how far apart those years are. What is that, 40 years, I think? Is that right? If you just do those, that would be 40 years. Okay, like that. So what you want to do is don't plug in 2025 there, because you would get a nonsense answer. Plug in 40 there, then you just do your calculation. Okay, so what you'd do to get the answer to the problem would be y equals negative 0.19 times 40 plus 83.75, and then you can do that on your calculator, and then that would give the predicted value there. And it'll be some percent, and it should be pretty logical. Okay, so I'll just go, I'll put it in, negative 0.19, and then times 40, and then plus 83.75, that'll give the predicted amount, okay? Which that makes a lot of sense to me, because this thing is going down, so we would say about 76.15% is the predicted value, okay? And we do that. This is something that we actually do with statistics, and we can take data and we can build equations out of it, okay? The next question becomes is, where does that model come from? Well, it comes from a computer. That's what I'm going to show you also here today, okay? Okay, the last problem on this page says, use the model to estimate the first year for which fossil fuel production is less than 70% of the total energy production. To answer this question, you would want to write down the mathematical model, and let's think about this then. Okay, so what do you guys think I would do with this equation and the 70% to solve this problem? What does X represent? X is number of years plus 1985, right? What does Y represent in this problem on your graph? right? So you could take the 70 and plug it in there, right? Okay, you could solve the equation, and that would tell you how many years past 1985 it would take for that to get down to 70. Okay, so what you're going to do on this is you're going to solve this equation. So plug in a 70 for y, and then go ahead and solve your equation. So what you're going to have is 70 equals negative 0.19x plus 83.75. Okay? And let's see what we get on this then. You have to give the year, okay? So this is a pretty basic equation to solve, so you want to just isolate x. So we can subtract from both sides, okay? And if I do my calculator, I'll take 70 minus 83.75, and that's going to give negative 13.75. I'll cross that out, 19x like that, and then finish up by dividing by the number in front of x, and then we should have a reasonable solution here, hopefully. Okay, so let's see, I'll take the negative 13.75 divided by negative 0.19, and what I'm getting is I'm getting x equals about 72.4 is about what I'm getting. So what do you do with the 72.4? Add it to 1985, right? Okay, you're not going to say in the year 72.4. That's what it's going to be. Okay, remember this is years after. So what you do is 1985, and let's just use 72. You have to use the 0.4. So that would be 715. Okay, like that. So it looks like the year would be 2057. Okay. Now, is that realistic? Probably not. It's just sort of an example because things will change on this. I mean, you don't know what's going to happen with inventions. My hope would be by 2057 we have nuclear fusion and the world will be normal again. That's what I think. It'll solve so many. It'll be like a new industrial revolution if we get fusion energy, and we never have to worry about any new energy source ever again. It's that good. Okay. Okay, so let's go next page. Any question about what I did? With that, and the graph and scatterplot? Okay. Okay, so now we're going to kind of get into calculator usage here a little bit and how you find that mathematical model. What I've got on this page is these are just a couple of pictures of scatter plots. And what happens is usually if you take data, it doesn't make a perfect line, but you can usually tell if it's linear if it kind of makes a line. So those would be things that are basically linear relationships. What we can do is with statistics, we can find the line that best fits the data. Okay, we're not going to show you what stats does, just going to show you how the calculator goes. So all this stuff here, I just typed this out for you. This is what you're going to do on a calculator to do what we call our linear regression equation. Okay, so that's what that's going to be doing. And if you brought your calculator, you want to bring this out, get that out so you can do this along with me. Okay, if you don't have a calculator, you can't do this at all. Okay, so let's go ahead and this one on the next page, let's go ahead and do a scatter plot. So this one is doing this basically. We're going to just look at the average annual temperature. So I'm only going to look at this right here. So we got years, and then we have the temperature. Okay. All right, and this is an average, this is a temperature in the United States. Okay. All right, so let's draw a scatter plot. And what we're going to do with this is we're going to start this kind of the same way. We're going to say if x is equal to 0, that's going to be the year 1965. Okay? I don't want you to start your graph at 1965. I just want you to probably count it every 10 years the way it has here. So you'll just say x is years past 1965. Okay, and then just kind of do your x-axis by 10s, okay? So we'll just go 10, 20, And let's see, how many years is that apart? About 50 probably. That's probably 50. I was born in 1962, so that's probably 50. Okay. All right, so we got that. That's good enough. Okay, now let's see. For the average annual temperature, just do what I did on the last problem. Just put a little squiggly line there, and then that way we can start at like 50. You could even start at 51 because none of the values here get smaller than 51, so I would just be inclined to say 51, 52, 53, 54, and maybe up to 55, just so that you can fit all your data. And if you do a scatter plot, don't make it so tiny. Spread it out so you can see there's a line. Okay, then what you're going to do is you're just going to plot these points. Okay, so it's going to just line by line just plot these points. So this would be when x is 0, you are up 51.69. So just estimate where 51.69 is. Okay, then you go to 10 years after 1965. Then the temperature went down a tad. Okay, then you go to 20. Then it still went down a little bit. Just estimating. And then it starts kind of jumping up. When you go to the 30, then that's up to about 52.6. Then when you're at 40, you're up to 53.6. And then the last one, you're up to about 54.4, like that. Okay? If you guys have ever studied some of the data that NASA and scientists have put together on global warming, okay, it's not just sort of a gradual thing. It's kind of taken off in the last 10 to 20 years. Okay? So it's kind of, in reality, it's probably not a line, but that kind of looks like a line. It's kind of can make a line. So that's going to be a linear relationship that we have. Okay, so that's a scatter plot, which is just plotting points, and be sure that you label everything on here. So you would also have to label that's the average temperature of the U.S. in degrees Fahrenheit. Okay, so I mean, if you're going to produce a graph and show somebody, you want to label everything, okay, because otherwise it ain't going to mean anything to anybody. Okay, now here's what we're going to do. So get your calculator out, and I'll kind of show you what you're going to do here. You don't need to write down the steps because the steps are on the previous page. So what I'm going to do is I'm going to do this. I'm going to take a little snapshot of this table that we need, and then I'm going to go to the previous page so you can kind of refer to these steps as we do this then. Okay? So I'm going to scroll back up to this page, and we're going to follow these steps. And if you didn't bring your calculator, you're going to need to know how to do this and do this outside of class. Okay, so here's what you're going to do to begin with. All right, the first thing that you do is we're going to put all these points in, and you have a stat button. So your stat button is located in the third column down right here. So you press your stat button, and then you press edit. So it's highlighted on edit, so then you press enter, like that. Okay, so just do those things, stat, edit, enter. Now, what you should have, depending on your calculators, you should have lists, L1, L2, L3, and L4, and so forth. Is anybody not seeing that? Tell me honestly, are you not seeing L1, L2?
How do you clear it?
Okay, like this. What you do is stat, just follow this here, go stat, edit is already highlighted, then press enter. Okay?
Well, how do you clear it?
That's what I'm asking, okay? So do you already have stuff in there?
Yeah.
Yes, if you have stuff in here, like for instance, if you have something like this, and you want to clear it out, what you do is if you have some lists in there, go up to the top, get it on L1, press clear, and then press enter. I like that. Now that's what this says. I tried to write everything down on here that you need to know. That's how you clear out data, okay, like that, okay? All right. So now here's what you're going to do. You're going to put in the data values. Now remember the data, we're not going to start at 1965. We're just going to go 10, 20, 30, 40, 50, and so forth like that. So you want to just go straight down the list and put these things in. So 0, 10, then 20, 30, 40, 50, and then stop when you get to 50, kind of like that. So you want to put that in, and then you want to go to Y, or L2, and then you put the temperatures in. So if you put that in, we'll have 51.69, and then 51.5, 51.3, and so forth. Then I got what, 52.65. Always got to press enter to put it in, then 53.64. And then the last thing you put in is 54.4, like that. Okay, and don't put anything else in. So you first thing you got to know is how to put your data in. And what this part right here is telling you is this is how you put your data in, so your notes will remind you of how to do that. Okay? Now, what we're going to do is we're going to find a regression equation. So we're going to do this information right here now. So if you've got your data in, then you're going to do this. Okay? So just do exactly what this says here. So press your Stat button. Okay? Go to Calc. So see, there's a Calc menu. So you move over with your right cursor until you get there. Okay? Then you go to Step 3, which is a linear equation. Then you press enter, and it'll give you the what we call the line of best fit. So Stat, Calc, linear equation, press enter, and then it'll depend on your calculator. What you got to have is you should have L1, L2 coming out. If it isn't, you probably want to see me after class so I can fix your calculator. You just go down to calculate, and then what you do is just press enter when you do that. Okay? Then what will happen is it'll give you the regression equation. Okay? So when you're doing this, just make sure that you refer to your notes to follow those steps. I'm going to go to the next page and have you write down what the calculator gave. So on part B, what we have is you get what comes out on the calculator is y equals ax plus b. It's going to tell you what a is, so I'm just going to maybe round that to like 3 decimals, so I'm going to say 061. And then b, I'm going to say 51.007, like that. Okay? So the answer to the regression equation is y equals 0.061x plus 51.007. Okay, so that's your equation. Okay? So that's something that you want to know how to do with a calculator, because if you don't have a TI, there isn't any way you're going to ever do this. You can't do this by hand. It's too complicated. Okay? So what I want you to do then is one more thing. I want to show you kind of how to do the scatter plot on your calculator. Okay, so I'm going to go to y equals. If you got all your data in, you want to just clear out these two things like that. Somebody have a question out there?
Yeah, what you do, you just went back or something? Out of the
yeah, what do you have? Do you?
I'm still in the linear regression.
Okay, you still here?
Linear regression.
Yeah. Are you still? Oh, you're still on the regression.
In the actual equation.
Okay. Let me show you. Okay. One thing that you want to do if you want to go to another screen on a TI, then what you do is you do this. You press second mode. There's a button that says quit. So you should see the button mode right there, and it says quit above it. So if you go second quit, then it just takes you to a clear screen.
Okay.
Okay, that's how you can always get to a clear screen, is by doing that. Okay, now what I want you to do is this. Go to the y equals button, press y equals, and then put in the regression equation. Okay, so we got 0.061x, and then plus 51.007, like that. Okay, then press graph, and I'll show you kind of what we just did. So once you get that in, if you press the graph button, okay, basically what will happen, whoops, I got to do one more thing before you do that. Okay, so the way you do a scatter plot is like this. So if you want this scatter plot to come out on your calculator, you have to do these things. Okay?
You went to y equals. I'm trying to find that.
Okay, right here, y equals, right here. Okay, you press the Y equals button at the upper left-hand corner.
Y equals in the, oh, the top.
Okay, and then that's where I put in the regression,
Okay.
the 0.061x. Right, I put that in. Okay. Okay, now let me show you how to do a scatter plot on your calculator. The first thing we're going to do is we got to set up the window. So I'm going to press my window button. Then I'm going to put in what the scatter plot tells. So we're going to go 0 to 50, and then we scale by 10. I'm just telling the calculator to do the same x-axis that I had you do on them. Okay, now on this, let's see, we've got to start. Now you can start anywhere you want to. You can start at 50. So or you can start at 0. I'm just going to start y at 51 like we did. And then I'm going to go all the way to 55. Then I'm going to scale that by 1. Okay, so that's the window that you could put in. All I'm doing is getting the calculator set up so it'll do the same scatter plot. Okay? What's that? That's telling you what it's going by. So like this is, X is going by 10, 10, 20, 30, 40. Y is going 1, 2, 3, 4. So it goes like that, okay? Okay, so you do that. Now, the other thing that you do is you go to Y equals again. So press your Y equals button. And then you should get the cursor so it's blinking on plot. And then you press enter. Okay, if you want a scatter plot to come out, that plot has to be highlighted. Okay, now if you press graph, this is what should happen, is you should have your dots, and then the line should go through that data. That's what should happen. Okay, how many people don't have a graphing calculator with them? That's really bad. Okay, I told you you can rent a calculator.
No.
Okay, you can't. Did you ask?
Wait.
So I think Student Services does have calculators. What
No,
we?
I went